In this chapter, we will be looking at quadratic equations. In this lesson, we will be looking at applications with quadratic equations.
Okay, hi everybody. So in this lesson we're going to be taking a look at applications of quadratic equations. Okay, and so we're looking at word problems, and I know that's not everybody's kind of favorite thing to do here, but I also know where the issue tends to lie. Okay, so we got some steps here to follow here. First of all, you're going to introduce a variable to represent the unknown value, typically the thing that you're looking for. Okay, now that is not always the case. Just something to be aware of. Sometimes that variable is like an intermediate step between what you don't know and what it is you're looking for. That doesn't happen all the time, but that's just something to consider here. It's this part right here. Form the quadratic equation from the given information. It's that translating from words into the mathematical symbols. That's the hard part. That's what people really struggle with. Because typically at this point, you're solving the equation isn't usually that big of a deal. Particularly in this chapter, because you already know what it is you got to do here. You're going to do factoring if you can. And if you can't, you're going to use the quadratic formula. Okay? And so we already have kind of a surefire tool for getting the solution to that. And then we're going to state the solution, linking it back to the problem. Okay? So we want to make sure that you're actually answering the problem and interpreting your answer, because it is not uncommon to watch students get an answer, get a value, but still not know what the answer to the problem is because they're not quite sure what it is that they're looking at. So in order to make sure that you communicate that you know that you've solved the problem, okay, you want to make sure you state the solution like that. I sat in a lecture once with a gentleman that said there are two steps to a proof. Now I know this isn't exactly a mathematical proof, but the idea is very similar. The first step is finding the proof, and the second step is proving to somebody else that you found the proof. That's kind of what's going on here. We need you to solve the problem, but then we need you to communicate to somebody else that you solved the problem, because if you don't do that, then really you haven't solved the problem yet. Okay, so the communication math is really important. Anyway, let's take a look at some examples here of word problems. Okay, so for our first example here, let's go through and read the question here. The height h in meters of a projectile above the ground at a time t seconds after launch is given by the function h of t is equal to negative 4.9 t squared plus 16t plus 2. Okay, so we're going to write an equation that could be used to determine the time it takes for the projectile to reach the ground. Okay, so we're trying to determine the time it takes for the projectile to reach the ground. So in other words, t, okay, t is the unknown variable that I'm interested in here. So I want to make sure that I leave the t inside that problem so that I can solve the equation for the variable t. Now, when it takes for the projectile to hit the ground, so here's this extra little bit of information that I'm being given that I'm supposed to put into this equation, okay, to create a new equation that I can solve here. Well, h represents the height in meters, and we have to assume in this case here that we are measuring this above the ground here. So for it to hit the ground, h would have to be equal to 0. So the equation that I want to build here is that the height at 0 is equal to negative 4.9 t squared plus 16t plus 2. Okay? Now, this is now the equation that I want to solve in my next step here. It says algebraically determine to the nearest tenth of a second the time it takes for the projectile to hit the ground. Well, I've got my equation set up where my height is 0 and time is my variable. Now what I want to do is I want to solve that. Now factoring is probably not going to be my most efficient method because of that negative 4.9 in there. Okay, I'm going to have a hard time kind of ripping that apart in a way that's useful and meaningful to me. So instead I'm going to use the quadratic formula. And I know that a is going to equal negative 4.9, b is going to be 16, and c is going to be equal to 2. And so now I can plug that in. And this time the variable, now normally with the quadratic formula, in a previous lesson you would have seen me use x equals and then the negative b plus or minus and the rest of the equation here. But now the variable, the independent variable I'm looking for is t. So t is going to equal the negative of the b, so negative 16, plus or minus the square root of 16 squared minus 4 times a, so here's my negative 4.9, and then multiplied by 2, and this is all over 2 times the a value, 2 times negative 4.9. Now I was a little concerned at first here when I saw that negative 16, okay, because that's kind of setting the stage for this expression to become negative. But then I'm dividing by a negative, and I know that that's going to turn this into a positive. Okay, now, I could go through the process of simplifying this a little bit, but regardless of where this, of how it simplifies, I'm being asked to evaluate the answer to the nearest tenth of a second. So I'm just going to use my calculator. Now, I know that for a lot of people, using the calculator is not a problem. You're very comfortable with it. But I also know that there's probably an equally large group of people out there where taking this information and plugging into the calculator can become actually a little bit of a chore. And people don't get it consistently correct here. Now, almost every time I do something like this in class and I have students working with me, and there's an issue, and the hand goes up, and then it's like, I've put this into the calculator, I don't know what's going on here. In like 90% of the cases, it's because of a set of parentheses that was missed. So before I maybe jump into this, let's talk about what's got to happen here. Remember that this line here represents division. But more than that, that line implies a set of parentheses around the numerator and the denominator. So that all that work that I'm seeing in the numerator has to come first before the division. This multiplication here in the denominator has to come first before this division. Okay, so I need to keep that in mind when I plug this in. So now what I'm going to do to start off with is here, I'm going to start with this set of parentheses. So there, and then negative. And if I'm using the Texas Instrument calculator here, and actually basically any other calculator like this, there's usually two symbols here that look like subtraction here, but this is the negative sign, this is the subtraction. And when I'm starting with a negative like this, I want to use the negative symbol here. So negative 16. I don't need the parentheses here around the 16. There's nothing wrong with putting them there, but I don't need them because it's just positive 16 there, and so the negative of positive 16 is just going to be negative 16. I will start with the addition, so plus the square root. And here, I don't need to worry about a sign error here because this is positive 16. And I know that when I square a positive, I'm going to get a positive, so there's no problem with that. Minus 4 times negative 4.9. I want to make sure that I'm using the right symbol for the negative there, not subtraction. Multiplied by 2. And now it's just a very little thing, but you need to make sure that you use your arrow key to get out from underneath the square root. Okay? Because if you don't, then the calculator thinks that everything else that you type from this point on is still under the square root. I also need to close the brackets for the numerator so that the calculator knows to do all this first, divided by, open up brackets, 2 times negative 4.9. And again, I'm going to put that in brackets. So the calculator knows to do what's inside those parentheses here first, and then it'll do the division. When I press enter, okay, when I press enter, I get negative 0.12054, blah, blah, blah. But remember, the question only wanted me to give you the answer to the nearest tenth. So in this case, I'm going to get negative 0.1. So remember that the nearest tenth, okay, that's one place after the decimal here. And I'm going to actually put an approximate symbol. I'm going to, because I had to round this, so it's not exactly equal to negative 0.1, it's just approximately equal to. Now, that's not my only solution. Not only that, it's a solution that doesn't really make much sense, okay? Because that's happening at a negative time, and that doesn't make any sense. Now, there is a reason why that negative does show up there. It's just that the projectile doesn't follow that part of the parabola. Okay, the parabola only exists after the person has thrown it. But anyway, let's take a look at the positive part of this. Sorry, the negative part. I'm going to replace that addition with a subtraction here. Now, don't retype the whole thing. Some of you can just use your arrow key to go up, highlight that, and press enter. But if you've got one of the older calculator models here, if you just press second enter, the operation above the enter button is entry. what that does is that retypes that whole thing for you. So now all you've got to do is just go back and edit it. So I'll come back and I'm going to replace that addition right here with a subtraction. Press enter. And I get 3.3858 blah blah blah, which to the nearest tenth will be 3.4 seconds. So I know that this answer here doesn't make any sense, but I write it though because I need to communicate to my teacher, your instructor here, that you did find that root, that you found two roots here, but one of them doesn't make any sense here. So when does the projectile hit the ground? The projectile hits the ground. Projectile hits the ground at 3.4 seconds. Okay, so we're effectively rejecting that negative root because it doesn't make any sense. So I know I went through that a little bit slowly, but I hope that makes sense. Okay, everybody, we're going to take a look at this next question here. Now, there was a little bit of an issue with some of the wording here, and you can probably see that I've edited some stuff here. It's threw me off a little bit. So I'm going to go through this again here. I'm just going to make a couple little subtle changes here. So a special enlarger bulb is designed to enlarge photographs. The shape of the reflector, and that's what we're going to focus on in this question, is the reflector, on its side can be represented by the quadratic equation, and we're given this equation, 0 equals negative 2/9 x squared plus 4/3 x. Now, just to be clear here, the shape of the reflector would be represented by the quadratic function here, negative 2/9 x squared plus 4/3 x. Okay, you really need to have the equation here. And I'm going to zoom in a little bit actually. You really need to have both variables there so that you can draw out the picture to get the shape of the quadratic or the parabola. What we're looking for here are the endpoints. So essentially what we do, we've got this parabola, it's going to open down, okay? It's going to hit the x-axis at two different points right here. These x values here. Now that's where the y coordinate is going to go to 0. And for this particular problem, what that is doing is representing the endpoints of the reflector. So the reflector is this parabolic shape that starts here and ends here. And that's what we're looking for. Okay? So now we're going to take this equation right here that they gave us. Okay? And I'll write this out again. So it's going to be 0 equals negative 2/9 x squared plus 4/3 x. And what we're going to do is we're going to rewrite this using only integer values, which means I'm going to get rid of the denominators here. I'm way too lazy to be working with these kind of fractional coefficients. So I look at the denominators here, and I've got a 9, which is got two factors of 3 in it. And over here, I've got a factor of 3 in the denominator. So in order to cover both of those denominators, I'm going to multiply by 9. I know that 9 will cancel with that 9 right there. And then in this 9, one of its factors will cancel with that 3 right there. So now I'm going to distribute that 9 to all three of those terms. So it's going to be 9 times 0 is equal to 9 times negative 2/9 x squared plus 9 times 4/3 multiplied by x. Now I'm hoping that a lot of you are very comfortable with this operation, so you don't have to do this in necessarily steps. You can jump to the final answer here. But 9 times 0 is just going to be 0. That's one of the big benefits of having the equation equal to 0 is I can do stuff to the equation and I know it won't change that side. 9 times the negative 2/9 here, well, the 9s are going to cancel. I'll be left with negative 2x squared. And then here, only one of the factors of 3 and the 9 will cancel. The other factor of 3 will be multiplied by the 4, and so this will become plus 12x. Okay? And so this is the equation now that I'm going to solve. The next question here says determine the diameter of the bulb. Now actually what we mean here is reflector. And in this case here, it's actually not going to be x. Okay, I think the intention of the problem has changed a little bit from when it was first when we started working on it here. The diameter of the reflector by finding the solutions of the equation in A. Okay, so we're going to solve. Okay, we're going to solve for x here. We're going to get two values of x. Now this is going to be a great example of a question where just having the x value doesn't actually get you the answer you're looking for. And I'll show you in just a second here. But let's solve this equation first. So we've got 0 is equal to negative 2x squared plus 12x. Okay. Now, there are a few things you can do with this, but we know that we're going to solve this by factoring. What I would do here is I see that there's just two terms here, so I'm wondering if it's a difference of squares. Because of that, I know this is not a trinomial, so I'm not going to be doing guess and check or decomposition here. But before I get into any of that, I'm going to take out what's common, and there's a common 2 there, and I will take out the negative 2 because when I have my expression here, I like to start it with a positive, so I'm going to take out the negative. There's also a common x, so I'll take that out as well, and that's going to leave me with x here minus 6. Now, when I look at this expression right here in factored form, I've got a negative 2 multiplied by x minus 6. Well, those factors all multiplied together are producing a 0. Well, it's not the negative 2 doing it. Multiplying by negative 2 doesn't produce a 0 as a result. But if that x is equal to 0, that'll do it. And if x minus 6 is equal to 0, in which case I would solve for x and I'll get 6. If x is equal to 6, that will also make this equation equal to 0. Okay, so now the question is asking me to find the diameter. Well, here are my two values of x here. Now let's bear in mind, what did I just find? Well, what I found here was the two spots where this parabola hits the x-axis. It hits it here at 0 and here at 6. So the difference between these two, and I'll just change colors here, the difference between those two is going to be the diameter of the reflector here. And so I don't think it takes too much here to realize that if this is 6 and this is 0, then the distance across here is going to be 6. Okay? So we can write now that the diameter of the reflector is 6. And I was hoping I could do a little bit, I could be a little bit more specific in terms of units, but I don't have any units here. So we'll just say 6 units. That's the math way around that problem. Okay, for this next problem, let's have a little look at it here. The paved walkway from the main school building to the phys ed block of a school is L-shaped with a total distance of 230 meters. A student taking a shortcut diagonally across the grass shortens the distance to 170 meters. Determine the lengths of the two legs of the paved walkway. Okay. Now, when you're dealing with more of a geometrical problem like this, it really does help to draw this out. So we know that we've got this L-shaped sidewalk. And okay, when they say L-shaped, the assumption is that that's going to be a 90 degree there. I don't know what the lengths of these two sides are, so I'm going to call this one X here. Now, but the thing is, I could call this distance here Y. Totally could, but I mean, no matter what, if I know that this is x, and I know that the total distance here is 230 meters, well then, this has to be 230 minus x. And even if I used a y here, at some point I would end up producing this expression here. It's some way along the work here. It's just the way that works here. Like if I knew that this was 30 meters, then I would know automatically that this had to be 200 meters. Okay, that's just a given here. The next bit of information we know is that the diagonal here, from here to here, is going to be 170 meters. Okay, so those are the bits of information that we've been given. Now what I want to do is I'm going to seek a relationship between those three, and it's probably fairly obvious that the relationship that we're looking for here is the Pythagorean Theorem. Okay, so I know, based on this here, that x squared plus 230 minus x squared will equal 170 squared. There we go, the Pythagorean Theorem. You know, this is one of those things that when you learned that, that was a gift that you were given that you will take for life. The Pythagorean Theorem shows up over and over and over again in math in all sorts of different locations. So it's important to be familiar with it. Okay. Now, one other little thing here before I continue on with this. Notice that I am starting my work on the left-hand side of the paper here, the space here. I'm going to work down and then down in columns. Okay. Too often I see students that'll start here in the middle and then they get stuck because they run out of room and then they got to continue their work over here, and it's very hard to follow. remember that part of the process here is communicating. And if your communication is confusing, then you haven't solved the problem. Okay, at least you're making it hard to figure out if you did solve the problem. Now let's take a look at the algebra here. I need to square this expression. Okay, the x squared is not the issue here. It's this 230 minus x that's squared. Remember that means this. Now I'm going to take my time with this because this is one of the more commonly mis-executed steps in mathematics. Okay, and I won't even bother squaring that quite yet. I'll get to that in a second here. The squaring of the 230 minus x gets done wrong all the time. Too many people believe that you can just distribute the square, just square this minus the square of this, and that does not work like that. That doesn't happen. Exponentiation doesn't distribute over subtraction. If these two were multiplied together, that would work. But because there's a subtraction there, it doesn't work like that. And so what we need to do is we need to put the two binomials multiplied together. And then what we're going to do is now we're going to distribute the 230 to both of those terms, this 230. So I will end up with 230 squared minus 230x when I distribute the 230 to this 230 and then to this negative x. And now I'm going to take this negative x and distribute it to get negative 230x plus x squared. And this will equal 170 squared over here. So when I multiply that all out here, I'm actually getting 4 terms that I will now simplify, as opposed to just the 2 pieces that most people do. Most people immediately do some work and they forget about these 2 terms in the middle. They walk right over it and then wonder why they got it wrong. Okay? Please take your time with that and make sure that you are expanding that properly. Now, let's group together like terms here. Notice I've got 2x squareds. So this is 2x squared. I've got a negative 230x and a negative 230x. It's going to be negative 460x. And now I'm just going to do this on my calculator off to the side here. I've got 230 and I'm squaring it. And then what I'm going to do is I'm going to move that 170 over after I square it because I want this to be equal to 0. And when I do that, I get this beautiful 24,000. Oh, so kind of a big, ugly number there. Well, that's okay. That's okay. Now, this is the equation that I'm left with. It's a quadratic. It's set equal to 0, so I'm feeling good about this. I'm going to multiply everything through here, first of all, by 1/2, though, because I'd really like to get rid of the factor of 2, just to make these numbers as small as possible. So when I multiply through by 1/2, I will get x squared minus 230x plus 12,000 is equal to 0. Okay, now I need to solve this by factoring or the quadratic equation. Now I suspect that most people watching this, okay, we'll look at that 12,000 and get a little bit thrown off, and we'll go, I don't know, 2 and 6,000? No. 3 and 4,000? No. And it starts to get a little bit intimidating to try to figure out how we're going to get that to work. But that's okay. I tell you what, let's just jump right into the quadratic formula. I suspect that is going to be the kind of the default setting for a lot of people. Let's just do it. No problem with that at all. A is equal to 1. B is equal to negative 230. C is equal to 12,000. So my x value here is going to be the negative of the b value plus or minus the square root of, now remember, it's in brackets, negative 230 squared minus 4 times a times c, 12,000. And this is all over 2 times 1. Okay, so now I'm going to let my calculator handle the work here. So remember, I put parentheses around the numerator, and I'm going to get the negative of negative 230. Now I already know that's going to end up being positive 230. That's fine. I'm just going to write that out there. Plus the square root of And here I'm going to put brackets to make sure that that negative is included when I square that. So negative 230 squared minus 4 times A times C, my 12,000. I got to get out from underneath the square root there, close my parentheses, divided by... Now in this case, I could put the denominator in brackets, but when I look at that, I'm just getting 2 times 1. I already know that's only going to be the number 2, so I'm not even going to bother. And here, look at that. I get the number 150. Wow, that is super nice. That probably means that I should have been able to factor that expression. But that's okay. That's okay. So what? Factoring would probably have taken me more work to find those numbers. This is great. Now, I still got to go through and find the other root, though. So I'm going to go back up here, and you can press second enter if you need, or just go up like I did and just highlight that expression. I'm going to edit this by changing the addition there to a negative, to a subtraction. Press enter. Oh, and I get 80. So I get these two nice solutions here. So now the question is, well, what is x? Is x 150 or is 180? Well, let's take a look at what happens here. Because the question said I want to determine the lengths of the 2 legs of the paved sidewalk. Well, let's just say here, okay, let's just say x is equal to 150. Then the 2 sides of my sidewalk become 150, and then down here was going to be 230 minus 150. Well, that's going to be 80. Oh, and it should be clear to me what's going on here. So if x is equal to 80, and I put 80 here, that makes this side here 150. Oh, so that's why both of those numbers popped out as solutions, because when I labeled my triangle, okay, I really don't know which one of these is going to be the larger side or the smaller side. Now, granted, the way I drew it made it clear that I thought x was going to be the smaller one, but the algebra that I didn't know the difference, so it didn't know whether this was supposed to be the large side or the small side. So what we know here is the lengths of the 2 legs are 150 meters and 80 meters. And there we go. Okay, everybody, let's take a look at this next question. It's a bit of a long one. But the nice thing is the equation is given to us here, so that's cool. It says, last year a theater company had 720 season ticket holders. The manager of the theater company has decided to raise the price of the package of season tickets to generate more revenue. The existing cost of the package is $140. Okay, so that is an important bit of information. We're starting, okay, the value starts at 140. Market research company he hired reports that for every $5 increase, we're going to add $5, but we're going to do that over and over again. So every time we change the price, we're going to add $5. So it starts at 140. The next step would be 145, 150, 155. But every time we do that, 20 season ticket holders would not renew their tickets. So this is going to go down 20. This is going to go up 5. So the manager needs to generate $102,000 in revenue. So use the following quadratic equation to determine the number of $5 increases that would take. Then determine the cost of the package of the season tickets. Okay, so here's the equation that we're given. Now I want to take a little bit of a closer look at this. So this is how much the manager wants to generate. So this has got to equal this right here. So what we've got here is we've got the price with a change multiplied by the number of people coming minus the change. Now, notice here that I've got the 5 multiplied by the x. So I was going to increase the price in these $5 increments here, okay? So what the x must represent here, x must be the number of $5 increments. And we need to be clear about that right from the beginning, okay? Because it's so common for students to misinterpret the answer at the end and think that x is the ticket price, okay? And I'll show you why that's makes no sense at the end. And yet sometimes students feel locked into a pattern of thinking where Well, once I found x, isn't that the answer? And the truth is, no, that's not always the answer. You got to know what it is you're working with here. So let me zoom out just a little bit here, and we're going to work with this problem here. So I'm going to rewrite this over here so I can give myself some room here. So 102,000 is going to equal, and now what I'm going to do is I'm going to distribute, okay, and multiply this out. Because what I need this to be is I need this to be a quadratic equation in the form ax squared plus bx plus c. Because if I'm going to factor it, or if I'm going to use the quadratic formula, I need to see it like that. And now remember, before you say, well, wait a minute, it's already in factored form, yeah, but it's not equal to 0. And so I would need to move this 102,000 over and then find some way to put it into here. And I can't do that when it's already in this factored form. There's too much going on. So I'm going to distribute the 140 through, so it'll be 140 multiplied by 720. And then this will be minus 140 times 20x. So I've just distributed the 140 to both of the terms in the second binomial. Plus, now I'm going to distribute the 5x. So it'll be 720 times 5x minus 20x times 5x. Okay, so there we go. So now I'm going to start to simplify this up a little bit. So 102,000 will equal, here we go, 140 times 720. I'm just going to do this on a calculator off to the side. Here we go, 100,800 minus, okay, well 20 times 140, that is going to be 2800, okay? And because sometimes I do that in my head and I do it wrong, I just want to make sure on my calculator that I got that right. 720 times 5 is going to be 3,600x. And then here, this is going to be minus 100x squared when I expand that all out. Okay, good. Now I got the pieces. Now I just got to put things together here. So I'm going to bring the 100x squared up front, because I like to have the quadratic term up front here. Then I've got this negative 2,800 here, and I'm going to add the 3,600 to it. And the difference between those is going to be an 800, so I'm going to get 800x. And then I've got this 100,800, and I'm going to subtract from that 102,000, because I'm going to bring that 102,000 over, and that's going to leave me with negative 1,200 here. It's kind of a huge drop. That was wonderful, actually. The difference between those was actually fairly small. So that's good for me. And that leaves a 0 here. I don't particularly like the way this looks right now. Like it's so much better than it was, don't get me wrong. But I don't like the fact that I've got this common factor of 100 here, and more than that negative there. So I'm actually going to take this whole expression, I'm going to multiply by negative 1 over 100. Okay? And once again, I'm gonna do this kind of a long way so that you see this, but I'm hoping that you can skip this next step here. When I multiply by that negative 100, it's going to be negative 1 over 100 times 0 equals negative 1 over 100 times negative 100x squared plus negative 1 over 100 multiplied by 800x. Okay, and this will be well, minus 1 over 100x, sorry, there's no x over there, I don't know why I did that. Negative 1 over 100 multiplied by negative 1,200. Now I'm going to do all the pieces here. So on the left-hand side, I'm just going to get 0. Over here, the negative 100s will cancel. I'm just left with 1x squared, which is amazing. 800 divided by that 100 is going to be, with a negative, will be negative 8x. That's wonderful too. And then over here, the result of negative 100 times negative 1,200 is just going to be positive 12. Well, that's absolutely phenomenal. This is such a nice little quadratic here. I'm going to try factoring this. Now, if I can't factor this really, really quickly, I will go and use the quadratic formula here. But I think I got a shot here because x squared will just break apart into x times x. And my factors of 12 will either be 3 and 4 or 2 and 6. or 1 and 12 for that matter. But I know 3 and 4, I can't combine those to get 8, but I can if it's 2 and 6. Now, that right there, that sign means that both of these are the same sign. They're either both positive or they're both negative. This one here means that in this case here, they're both going to be negative. So this will be x minus 2, x minus 6. And so the product of those two factors gives me 0, means that either x minus 2 is 0 or x minus 6 is 0, and then I can solve x is either equal to 2 or x is equal to 6. And so here we go. Those are my two values of x here. Now, the question was asking us to determine the ticket price, okay? So, is the ticket price $2 or $6? Both of those will do it? Well, no. Because x wasn't the ticket price. And besides, that makes no sense. I started at 140 and I was increasing the price by $5 increments. So I went from 140 bucks and I went up to 2, or I went up to 6. Well, that makes no sense. That's because x is the number of $5 increments. So either I increased the price twice, or I increased it 6 times. So if x is 2, then the ticket price, if I increase the cost of the tickets twice by $5, I'm going to go from 140 up to 150 bucks. And that will produce that $102,000 of money, or of revenue, if x is equal to 2. Or if x is equal to 6, oh, I shouldn't have written it like that, but anyway, or if x is equal to 6, then the ticket price, make sure you can read that, then the ticket price is, well, now I go back up to here. If I plug a 6 into that, 5 times 6 is 30. So I get $170. So whether I have it at $150 or $170, both cases are going to produce this revenue of $102,000. Now, if you're wondering how that's possible, basically what's happening here is as he increases the price, the value goes up, the revenue goes up, and then the revenue comes back down again. So what's happened here is, here's my $102,000. Okay, I hit a point right here at $150. Okay, and that's not exactly what the x value would be here, but you're getting the idea here. When the ticket price is 150, that's when the price is going up. But we hit a point here where there's a maximum revenue, and then people start to drop off, and the price drops down again, and it drops down again through the $170 ticket price. Anyway, that's what's going on if that didn't make sense to you. All right, let's have a look at one more. So this diagram shows a photograph measuring 8 inches by 6 inches surrounded by a mat. Okay, so the mat is the border here. The picture is 8 inches by 6 inches, and so just to be consistent, it looks to me like it's 8 inches this way and then 6 inches this way. Let's just say that that's the way that works here. So this is 6 inches wide, 8 inches long. The mat has the same width on all sides of the photograph. Now, we're not told what that width is, so let's just call that x. So it's going to be x across here, it's going to be x up and down here, x here, and x there. Okay? So now the total area, if the total area of the picture and the mat is 120 square inches. So in other words, if I find the area of this whole picture here, it's going to be 120 square inches. Determine the width of the mat on the side of the photograph. Okay. Well, what we need to do then is just to figure out the area, or sorry, we know the area. We need to figure out an expression for the area of this large rectangle, because that will include the picture as well. And that's what it says here, the total area of the picture and the mat. So we got to figure out now what this width is. Now, I've worked with enough students to know that this isn't 100% clear to everybody here, but watch this. This is 6 inches from here to here. Okay, I'm going to take this little bit, I'm going to just drop this down. So this distance right here is x, this distance right here is x. So the distance all the way across the outer rectangle here is going to be this little bit here, 6. Okay, so watch that. That's going to be 6 plus x plus x. Okay, so 6 plus this x plus this x, which means the width of this these two together here is going to be 6 plus 2x. The length, we already know that this is 8. Okay, and I'm going to draw this over here again. So here's my x. Here's my x, and you can probably already figure out where I'm going with this. If that's 8, the total length from bottom to top here will be 8 plus x plus x. So this right here is going to be 8 plus 2x. I know that area is equal to length times width. Now in this case, I know a little bit more than that. I know that the area is 120. I know that the length is 8 plus 2x. And I know that the width is going to be 6 plus 2x. Now what this question wants me to do is to solve this equation to figure out what the width of the mat is to the nearest tenth of an inch. So just like in the previous question, what I got to do is I got to expand this all out, bring everything over, and then solve. It's just the difference in this case was I didn't give you the formula. You had to, or sorry, the equation. You had to figure it out. So now what I'm going to do with this is I'm going to expand it out. So the 8 will get distributed. This will be 8 times 6, so 48, plus 8 times 2x, 16x. And then I'm going to distribute the 2x. So 2x times 6 will be 12x. And then 2x times 2x will be 4x squared. I'm not 100% liking the order that this is in, so I'm going to change things around a bit. I'm going to move things. So what I'm going to do here is I'm going to bring that 4x squared forward. Okay, and then what I'm going to do is I'm going to combine those two middle terms here, the 16 and the 12 here, so you get 28x. And then I've got 48 on this side. And I'm going to bring the 120 over, and the difference between those here, when I bring that over, is going to be negative 72. And I've left a 0 on the left-hand side. This is awesome. That's looking quite nice. Now what I want to do here is I want to get rid of any kind of common factor here. And when I take a quick look at these coefficients here, it looks like 4 is common. So I'm going to multiply this whole expression here, this whole equation, by 1/4. And now I'm going to do this a little bit faster than I've done it in the past year. I've kind of set an example with this. Now what I want to do is I want to just do this a little bit quicker. So 1/4 multiplied by 0 will just be 0. 1/4 multiplied by 4x squared, well, the 4's will cancel and just be left with x squared. 1/4 distributed to 28x, okay, will be 7x. Oops. And 1/4 of negative 72 will be negative 18. Now I've got this beautiful little quadratic here that I'm hoping I can factor. It looks so good here. Let's see if we can tear this thing apart here. So I know that x squared will break down into x and x. That's amazing. When I look at 18, I think of my factors of 18. Well, 3 and 8. Oh, sorry, 3 and 8. 3 and 6. Sorry, 3 and 6. 3 and 6, but there's no way I can combine 3 and 6 to get 7, regardless of the positives or negatives there. But 9 and 2. 9 and 2 I could. So I'll put the 9 and the 2 here, and I'm hoping that that works. This is negative, so one of these two is negative, one of them is positive. Because the middle term here is positive, I know that the larger two products here is going to be positive, so this will be x plus 9, x minus 2. And now when I multiply that out, do I get the positive 7x there? And yes, I do. Negative 2 and positive 9x. Okay, so that is the factored form here. So now when I multiply that out, I'm getting a 0, which means either x plus 9 is equal to 0, or x minus 2 is equal to 0. Whoops. Bring the 9 over. X is either equal to negative 9, or x is equal to positive 2. Now, between those two, I think it probably makes sense that the answer can't be negative 9. So the width of the mat okay, is 2 inches. And that's the solution to our problem. Now, I know it said here to the nearest tenth of an inch. Usually you'll find that teachers will do that on the off chance that somebody makes a mistake here with this and they end up using the quadratic formula, because maybe they make a mistake with a number here. And so this bit of information here, rounded to the nearest tenth, is there so that somebody that's maybe made a mistake here will at least know what to do with their answer. And so teachers will, for the most part, go through questions like that and kind of give them some guidance there. If a teacher normally would follow your work and they wouldn't dock you on everything if you made a little error there. So that's just a kind of a way of helping people get through the problem here. Now, I realize that this is not a question you're being marked on, but it's a question that you would go through here and to have that little discussion, you know, well, why is that there if my answer is kind of this perfect 2? That's why it's there, right? So if you see that in a different context, you'll have a better idea of what's going on.